let us see the next point of this unit, that is Euler's theorem. Euler's theorem is very important point of this partial derivative. Many times you get the question on the Euler's theorem compulsorily in the exam. So what is Euler's theorem? Basically the term x into dou u by dou x plus y into dou u by dou y, and another term, that is x square dou 2u by dou x square plus 2xy dou 2u by dou x dou y plus y square dou 2u by dou y square. Now these two terms can be found out by the Euler's theorem. So what actually Euler's theorem says is, if a function, if u is a function of x and y, which is what? Which is a homogeneous function of degree n, then this derivative or this term can be written as x ux plus y uy, can be given as it is equal to n into u, and this term, that is second term, that means x square uxx plus 2xy uxy plus y square uyy, this is given by n into n minus 1 times u. Okay, so this is the Euler's theorem. This one is applicable only for the homogeneous equations, and for the homogeneous equations of degree n, we can directly write this. Alternatively, this Euler's theorem can also be given as, if f of u, that means instead of this u we have f of u as a function of x and y, which is again homogeneous function of degree n. Okay, so instead of u, if there is f of u is equal to some function of x and y, and if it is a homogeneous function of degree n, then we can write the same equation, that is x ux plus y uy is equal to n into f of u upon f dash of u. And the second term, the second set of equation, that is what? X square uxx plus 2xy uxy plus y square uyy is given by z of u into z dash of u minus 1, where z of u is equal to n into f of u upon f dash of u. Okay, now this term is similar to this one. Okay, what we have to do, whatever the function we get here, no, first of all write it as it is, then take its derivative inside the bracket minus 1. Okay, that is the answer for this. Now based on the Euler's theorem, you get three types of questions here. Three types of question. The first type of question is verify Euler's theorem. Then in the second type, what we get is using Euler's theorem, u as a function of x, y. And third kind of question, which is repeatedly asked, that means it is having high chances of getting the question based on this third type, that is using Euler's theorem of the kind f of u as a function of x and y. Okay, so we will try to solve one question based on each of this, and that will help you to understand this Euler's theorem. So we got the question, first category of question, verify Euler's theorem. The function is given, u as a function of x and y is given here, 1 upon x square plus 1 upon xy. For symmetry we will write 1 upon y square as well. Now this question we have to, for this question we have to verify Euler's theorem. Now to verify the Euler's theorem, first of all we have to check whether the given function is homogeneous or not. Can you tell me whether the given function is homogeneous function? So what is mean by homogeneity?
Degrees.
Exactly. The degree of variables in each of this term should be even, means similar. Okay. Then we call that as a homogeneous equation. A simple trick to verify whether the given function is homogeneous or not is substitute. We can say put x is equal to capital XT and y is equal to capital YT in this equation. Now if I substitute, I will get u is equal to 1 upon capital X square into t square plus 1 upon x into t, y into t plus 1 upon y square t square. Now try to take out all the t terms common out of this. So if I take it, I will get 1 upon t square into bracket 1 upon x square plus 1 upon xy plus 1 upon y square. So if while doing this, if all the t terms gets outside, then definitely this is what, this is a homogeneous equation, and whatever the power of this t is called as degree of that homogeneity. So if I take this to the numerator, it is t raised to minus 1 half, and whatever the remaining term here is nothing but what, u of xy, you can say, isn't it? So t is completely outside, the power of t is minus 2, so we can say that the given function u is what, homogeneous, and its degree, that is n, is equal to what, minus 2. Now to verify, as per Euler's theorem, what we have to get here is x into ux plus y into uy is equal to n times u. That is nothing but n is minus 2, so it is minus 2 times u. So this thing we have to verify. So first of all we will try to find out the left hand side. That is what, LHS is equal to x ux, that is what, dou u by dou x plus y into uy, that is dou u by dou y. You can find out both these terms separately and then you can put it back here. Otherwise you can do it directly as well. So this is equal to x into bracket derivative, partial derivative of u with respect to x we have to find out. So if I do that, derivative of 1 upon x square will be what? Minus 2 upon. So it will be minus 2 upon x cube. Derivative of this term will be what? Plus 1 upon y is constant here. And derivative of 1 upon x is what? Minus 1 upon x square. Plus derivative of this last term will be what? 0 it is, because y is constant as far as the x is concerned. Plus y inside the bracket, again we have to take the derivative of this u with respect to y. Now derivative of 1 upon x square will be what? 0. Plus derivative of this term will be 1 by x is constant, and this will be what? Minus 1 by y square. And this will be what? Last term? Minus 2 by y cube. Isn't it? Now let us simplify this. So if I simplify, it will become, if I multiply this x inside, I will get minus 2 upon x square. If I multiply it here, I will get minus 1 upon the, see here x cancels with one of the x, so I'll get xy here. Then this is 0, Now if I multiply this y inside, one of the y gets cancelled here and I'll get here minus 1 upon xy. Then if I multiply it here, I will get minus 2 upon y square, because one y cancels with one out of these three. Then if I summarize, it will be minus 2 upon x square. Then this plus this is what? Minus 2 upon xy, and this will be minus 2 upon y square. Now if I take out this minus 2 common, whatever I get inside, you can check it, it is similar to what? The given question, that is u. So it is equal to minus 2 times u, that is equal to RHS, and hence Euler's theorem is verified. Okay, so in the second category, generally the question will be like, you have to find out this partial derivative, answer for this partial derivatives. So here, if you look closely, this first part is nothing but the first Euler's theorem, and this is the second Euler's theorem. So basically we need to find out both these answers and we have to add it together, then we'll get the answer here. Now if I look at this equation, sometimes what we get, the u as a function is not completely homogeneous function. Instead, the parts of this equation are homogeneous in itself. Like this equation can be written as some p plus q, isn't it? And separately we can find out p. For p, we can check it whether the given p is homogeneous or not. It is x raised to 7 plus y raised to 7 upon 3 root of x raised to 4 plus y raised to 4. And similarly, q is equal to log of x upon y. Okay, both these functions are homogeneous functions. And if I try to find out the same equation for p and the same equation for the q, and if I add it together, I'll definitely get the partial differential equation for this u. You're getting it? As u is summation of p and q, we will find this equation for p separately and for q separately, and then we will add it. Now solving these kind of questions is very simple. What we have to do, same procedure we have to repeat. Very first step is to find out degree of homogeneity. For that, what we have to do, we have to put x is equal to capital XT and y is equal to capital YT. If I put it here, I will get p is equal to root of x raised to 7 t raised to 7 plus y raised to 7 t raised to 7 upon 3 root of x raised to 4 t raised to 4 plus y raised to 4 into t raised to 4. Now if I take out this t raised to 7 outside, I will get t raised to 7 upon 2, because it is square root, it is under square root. And in the denominator, what I get is t raised to 4 by 2. Okay, and whatever the remaining is what? Function p of xy, isn't it? Because all the t terms we have taken outside and there is no other t term left inside this equation. So this is nothing but t raised to 7 by 2 upon this is what? T raised to 4 by 2 means t square. So if I bring it upside, it will be what? T raised to, what is 7 by 2 minus 2? 3 by 2 it is. 7 by 2 minus 2. 1.5. Isn't it? It is 3 by 2 into p of xy. Okay, so from this you can say that this is a homogeneous, p is a what? Homogeneous equation, and degree here is 3 by 2. And for q, again we have to put x equal to xt and y equal to yt. and you will get q is equal to log of xt upon yt. Here tt gets cancelled and this is what? Q of xy. Isn't it? Means same as that of the given question. Here no t comes outside or no t retains inside the function. Now this is very important that the bracketed term must not have any t. If you get something like x square upon y, what it will be? Tell me. Will it be the homogeneous equation?
No.
See, if I have log of x square upon y, is it a homogeneous equation? No. Because in that case, one of the t will cancel, another t will remain as it is. So inside the function, we don't need any of that t remaining there. So here no t is remaining here, so this is a homogeneous equation. Now can you tell me what will be the degree of this function? Homogeneous function का degree? How can I say? 0. It is t raised to 0, na? 1 is there, it is t raised to 0. So it is also a homogeneous equation and n is equal to 0. So from this together, altogether I'll write here x ux plus y uy plus x square uxx plus 2xy uxy plus y square uyy. Now all these terms I'll write it together. What is the answer for this? Tell me. The answer for this?
U.
What is it?
UN.
N into u, na? For this much it is what? N into u. For this it is what? N u. And for this much it is what? N into n minus times u. Okay? So this will be what? 3 by 2 times p now. For now it is p plus 3 by 2 into 3 by 2 minus 1 times p. Isn't it? This is the first term. And if I put this n equal to 0 here for q, that is 0 into q plus 0 into something, matlab 0. So all this answer will be what? 0. So finally this is equal to, this whole term is equal to, it is what? 3 by 2p plus
3 by 4.
This is what? 3 by 2 minus 1 is 1 half. So it is what? 3 by 4p. Or this is nothing but 9 by 4. 9 by 4 times p. Or you can write this as 9 by 4 and this whole term you can write here. X raised to 7 plus y raised to 7 divided by 3 root of x raised to 4 plus y raised to 4. Getting it? Now this is the very important category of the problems. Most of the time in the exam you will get the question like this. So u is sine inverse of something, this function is given and we have to find out this partial derivatives. Remember, whenever in the question these kind of equations, partial differential equations are there, it is nothing but the Euler's theorem. You have to understand this. Now here, if I substitute x equal to xt and y equal to yt and try to find out whether it is a homogeneous function, you can see that the t will retain inside this sine inverse function and this term will not be the homogeneous equation. So because of that, what we will do, we'll take this sine inverse on this side and then it will become sine of u is equal to root of x square plus y square. Now this right hand side term is homogeneous, you can clearly see. If you want, you can check it by putting x equal to xt, y equal to yt inside this, and therefore this sine u will become square root of capital, or I can say x square t square plus y square t square. Now here I will take the t square outside, then as it is inside the square root, it will become t into what? Function of x comma y, which is similar to this one, isn't it? So from this what we can say, sine u is what? Is a homogeneous function. Sin u is a homogeneous function of x and y of degree how much? N is equal to 1. This is what? 1. The power of t is nothing but degree. Okay, once you get this, then directly you can find out this from for this term, that is what? X ux plus y uy. You know the formula, what is it? N into f of u upon f dash of u. Now here this f of u is nothing but sin u. So this will become n is 1, f of u is sin u, and divided by derivative of sin u is what? Cos u. And so this will become what? Tan. Okay, so this is what? This is the answer for the first time. But this is nothing but what? Z of u. Z of u is what? Tan u. And to find out this one, that is what? X square uxx plus 2xy uxy plus y square uyy. You know the formula, that is z of u into z dash of u minus 1. So it is equal to tan of u into bracket. Derivative of tan is what? Sec square u minus 1. That's it.